Hello, everybody, and welcome to today's webinar. My name is Alex Graham. I'll be your host for today's session, and I have with me today Joanna Lee Meyer from Hexagon and Richard Schuler from SimScale. Joanna is a Business Enablement Manager for Multi-Physics at Hexagon, and Richard is a Product Manager for Structural and Physics AI at SimScale. And we're here today to talk to you about the Hexagon Marc solver availability on the SimScale platform, which I'm excited to announce is now available. So we'll be talking about what the partnership with Hexagon is all about, what is available in SimScale, and how to get access to it. Now, before we get started with the main presentation, I'd just like to remind everybody you're very, very welcome to put all of your questions into either the questions panel or the chat panel in your GoToWebinar window. Please drop your questions in there, and we will be able to address those in a live Q&A at the end of the session. So without further ado, I'm going to hand over to Richard. He's going to start off the presentation today. Over to you, Richard.
Great. Thank you, Alex. Thanks for having us today here in this webinar. I'm really excited, and thanks, Joanna, for joining. Yeah, I'm excited that we finally can announce the availability of Marc on SimScale, of Hexagon Marc on SimScale, a highly capable nonlinear solver, and hopefully it enables our customer to run simulations and get insights that they weren't able to get before. So quickly, today's agenda, we're introducing SimScale first for maybe the people in the audience who haven't really heard about SimScale yet and come rather from the Hexagon side. And then Hexagon will, Joanna will introduce Hexagon and Marc. And why from their point of view, this is a unique partnership with SimScale that we now started. And I'll take then over to show you how actually Marc on SimScale looks like, how you can use it, why that partnership is important to us and also to our customers. And in the end, we'll have a Q&A session where we are open to any questions. And really excited for this one today. So now to SimScale, might be a few people in the audience who don't really know what we do. We have about 600,000 users worldwide. Meanwhile, we're a cloud native simulation company. Now started 15 years ago. And in the meantime, we have thousands of organizations working with SimScale and millions of simulations in production. SimScale as a platform has always been cloud native. We have focused a lot on collaborative workflows within the customer base, but also between SimScale and our customers for user management, for process management. SimScale is scalable due to the cloud native development. So you can run thousands of simulations simultaneously. That is becoming very important in the age of AI, where the data bottleneck is really there in order to train AI models. It's not so much there now with SimScale, where you can really run thousands of simulations very fast and very easily. We enable broad physics from thermal, structural, electromagnetics, CFD, of course, and now with Marc, also highly nonlinear structural simulations. We have physics or AI already in production since a long time. So basically, you can train surrogate models for all of the physics that we see here on SimScale directly and deploy them to your users as well on SimScale. And we now more recent development is what we call engineering AI, where you can basically train agentic workflows also on SimScale, right? So setting up of certain types of simulations, running simulations together with an optimization workflow, and all driven with AI agents. That's it. In general, broadly about SimScale, we'll later see it in action. both the physics, maybe also a bit on the AI part. But now I'm excited to hand over to Joanna from Hexagon, who's introducing us to the company and to Marc, and yeah, why the partnership with SimScale is relevant also from their point of view. And yeah, over to you, Joanna.
Thank you very much, Richard. Thank you so much, Richard. Hi, everybody, and thank you for joining today. I'm Joanna, and I'm the Business Development Manager for Multiphysics at Hexagon. So earlier this year, I already had the pleasure of joining SimScale's webinar to help announce this partnership. And I'm really honored to be here again today for the official launch of Marc on SimScale. Thank you so much for inviting me, SimScale. In the next few minutes, I'll introduce Hexagon and our D&E division, give you a quick overview of Marc, our advanced nonlinear solver, and share what we envisioned for this partnership and why it matters. So let's start with Hexagon. Hexagon is a global leader in digital reality solutions. We combine sensors, technology, software, and autonomous technologies to drive innovation across industries. We have over 24,000 employees in 50 countries, and nearly 20% of our revenue we reinvest into our R&D. By doing this, we really hope that we can shape the future of manufacturing, mobility, and infrastructure. Our technologies touch 95% of cars, 25% of smartphones, and 90% of aircrafts produced globally. From design and engineering to production and quality management, we empower innovators, designers, and manufacturers to optimize every stage of the product lifecycle. At the heart of our mission is a simple belief. We believe that data should work for you. Our solution helps unlock the power of your data to accelerate innovation, improve sustainability, and transform operations. Whether this is through immersive digital twins, autonomous workflows, or advanced simulation tools like Marc, we are redefining what's possible, making innovation real for people and for life. So now let's zoom into our design and engineering division. Design and engineering at Hexagon, part of it was formerly known, some of you may know it as MSE software. We have combined with other divisions such as digital material, the horizontals, and also the autonomous and ADAS simulation. And now we form a complete suite to provide a digital thread for your simulations. We have over 60 years of legacy in computational engineering, beginning with NASA's commissioning of Nastran in 1965. Since then, we've been working very hard to build a reputation for getting simulation right first time. What we try to do is develop these world-class solvers like Marc that meets the performance, robustness, and capability needs of our customers. We really do believe in the power of people, ideas, and technology. So every product ever produced and ever created, we believe they exist to make life easier, more enjoyable, more predictable, and more productive. And to be able to do this, when technology is harnessed effectively, it should be able to elevate innovation and turn ideas into meaningful outcomes. With over 22 simulation products supported by 1,500 developers worldwide, our portfolio is both broad and deep. From multiphysics simulations for structures, fluids, acoustics, digital materials, system dynamics, to the autonomous and ADAS simulations, our offerings enable engineers to reduce prototyping, accelerate development, and hopefully ensure manufacturability. And it doesn't matter whether it's nonlinear FEA, CFD, or co-simulation, or the virtual manufacturing offerings. Our aim is to help our customers work smarter, collaborate seamlessly, and bring better products to market faster. With over 500,000 users worldwide, the trust Hexagon has earned across the global engineering landscape is evident. Our technologies are embedded in the workflows of the world's most recognized manufacturers and innovators. And you can see here, these companies span every major industry sector, from aerospace and automotive to electronics, energy, and life sciences. We understand how important it is for us to provide solutions, not just tools. Solutions that enable you as customers to improve the quality and consistency of supply, align and optimize processes across teams and geographies, as well as connect digital workflows to accelerate innovation and reduce time to market. From global OEMs to disruptive startups, we want to ensure all our customers with a wide variety of simulation needs and requirements, everyone should have a solution that is just right for them. And this is exactly where this partnership comes into play. So now, why have we brought Marc to SimScale, and why have we formed this collaboration? Marc has been trusted for decades to solve the most complex structural problems, from large deformations and contacts to highly nonlinear material behavior. It has the ability to handle that. It has an extensive array of analysis classes available: structural, thermal, coupled thermal diffusion, and structural, a coupled analysis between magnetodynamic, thermal, and structural. The list goes on. Marc is built to do that. Inbuilt, it also has these highly nonlinear material models. It has the ability to curve fit and determine the material model parameters from experiment data for you. It also has ability to create, to handle automatic remeshing and also allow high performance parallel computing. This solver is a powerful workhorse, and it's used behind a lot of our own solutions. This includes award-winning software SimEffect Welding, Digimat, MSc Nastran, Sol 400, and SimDesigner. When it comes to nonlinear FEA, Marc is the first and the last. And what this means is the first commercial nonlinear FEA solver, and it is also dubbed the last resort for difficult non-converging problems. It is known for its robustness, superior handling of contact and material convergence issues, and it has these algorithms designed to continue solving even in near singular or highly nonlinear conditions. Today, we know that engineers are pushing the boundaries of design more than ever before. And these nonlinear simulations are so important earlier in that design cycle. As a result, the need to incorporate nonlinear into structural simulation is not really an option anymore. It's standard practice. What was once the domain of expert analysts is now becoming the everyday expectations for even design engineers. We have long recognized this shift, and we know that to make nonlinear simulation truly accessible, we need to remove barriers to adoption. And that's why this partnership with SimScale is so important to us. SimScale brings a cloud-native, intuitive interface. And now with the addition of agentic AI powered by the large language models, it's changing the way engineers interact with simulation tools. Instead of spending time learning where the buttons are or deciphering new product-specific jargon, users can bring their existing engineering knowledge and get started right away. The agentic AI guides them through pre- and post-processing, helping them to set up analysis quickly and confidently and analyze those results without the need to become an expert in the software first. This means faster onboarding, faster time to first results, and more importantly, more time spent on the engineering task at hand. Less time learning a new tool and adapting to a new culture. With our robust Marc solver working behind the scenes, our vision for this partnership was to make nonlinear simulation more approachable, more collaborative, and more productive for engineers at every level. Now, standing here at this point at product launch, What SimScale has achieved so far and continues to build is, in my view, transformative. It's going to change how users feel and how they think about nonlinear FEA and make nonlinear FEA altogether more accessible than ever. Thank you so much again for being here today. I'm really excited to see how this partnership will continue to evolve and how it will empower you to do more with simulation, faster, smarter, and with more confidence. On this note, I will pass the session back to let Richard give you a demo of Marc on SimScale.
Thank you. Thank you, Joanna. What a great introduction. And now we can come over to the actual part where we hopefully see Marc in action on SimScale. But before that, I want to take a step back and really connect to what Joanna said at the end. Because we know that today AI is in everyone's mind. Everyone is using AI in their private life and sometimes also at work. So recently we did a survey with 300 engineering leaders globally on the topic of AI in engineering. And we got very surprising, or maybe not so surprising results if you know the engineering industry. And that is that most of the engineering leaders, a large majority, 93%, expect productivity gains from AI, but only 3% are actually seeing today very high impact of AI to the engineering processes. So the full potential is certainly nowhere near close to be touched today. As well, that we see that when users are already using cloud native simulation tools, they are much more likely to have an AI approach already available, and 6 times more likely to have clean data and centralized data, right? Because what we're seeing as well is that the siloed data not being accessible broadly is the main bottleneck that prevents engineering organizations from enabling a broad use of AI. And we're here to change that, essentially. So we say that across the whole engineering design process, it might look like this here or slightly different. There are a lot of opportunities for AI to support the engineering workflow and be more productive, right? Starting from just initially reading automatically the RFP, RFQ requirements, then maybe from 2D to 3D drawing, testing in the end, and reviewing the results. But also centrally, the engineering and physics AI means setting up from the requirements the simulation, running the simulation, and evaluating its results. That's where we see SimScale to play a central role, meaning in the engineering and physics AI and related fields. Again, what is engineering AI and what is what we understand with it and physics AI? Engineering AI for us is a way to automate the simulation process. So starting with best practices in-house to be able to automatically set up sound simulations in a very efficient and robust way. Right? People have been doing that in the past already, or parts of it, with rather brittle workflows sometimes, hard-coded, scripted workflows that are not as flexible than today's generation of agentic AI models. And then on top, so after you have automated or in parallel, right, to automating the workflows, you can speed up the core simulation computations with physics AI. So basically building surrogate models so that you get the response from your simulation evaluation within seconds instead of hours. So these are the two cornerstones of AI on SimScale, and we have proven that already in the past with many models, specifically on the physics AI, from examples of stress analysis, frequency analysis, also CFD, right, for valves, turbochargers, impeller design. This is already available today. And the great thing of SimScale as a platform is that this functionality of physics AI model generation and deployment on SimScale, as well as engineering AI, is completely independent from the solver. So now with Marc on SimScale, it is on the go, natively ready to also operate on the engineering AI foundation that we have on SimScale. So for example, here we use the simple chat interface on SimScale, the AI assistant, to tell it, right, based simply on the CAD model, to set up a crash analysis of the battery pack, right? This is the vanilla version that hasn't any specific or domain specific or custom organization specific information included, but you can customize this agent to follow exactly best practices, not only materials, but also simulation setup best practices, meshing resolutions, boundary conditions, and so on, according to your internal guidelines. Yeah? And with that, such new design tests can be set up in an automatic way. In the second stage, obviously also headless, so you can run it in a loop, in an optimization loop, without the need to actually put in the content into the chat window, of course. So now, with a large bridge over the AI topic, we can maybe have a look finally on to SimScale and Marc in action. So what you're seeing here is the SimScale dashboard. I'm looking here already into the spaces. That is the location where you can organize your teams, where you can create sub-teams that have access to specific content that share, maybe some sub-organizations and frequently work on the same projects, or you can split this out by customer and so on. And here we have, for example, in the application engineering, we have demo projects sorted out and so forth. And what we want to do is do a simple push rivet analysis here. And I'm showing you now how this works from scratch. So we create a new project. Let's call it push rivet. You can already share this with support. Typically, we do this later whenever you have an issue with your simulation, you don't know how to proceed. We have included the support into the platform. You can see it in a second, where you directly get connected with the support agent and can ask them questions. And for this, obviously, you need to share the project, because by default, all your data is private. It's not shared with anyone else. We can import any standard neutral or commercial file format, right? From CATIA to Creo, NX, anything. In this case, I'm picking something from the sample library where we have the push rivet assembly. So it's coming in. We can maybe edit the file in case we would need to clean it up. In this case, it's simple enough. So we could directly start with the simulation setup. So we click on create simulation. We can see here now the variety of different analysis types that we support on SimScale, from flow to structural and even electromagnetics. In this case, we go to the new nonlinear mechanical Marc analysis, and we select it. While I'm setting up, I want to remind you again to ask questions use the chat and the questions feature of the webinar tool to ask any questions you would like. We'll keep a few minutes at the end to really answer, hopefully, all your questions. So now that we have started the simulation, you see on the left side, the typical starting point of a simulation where we try to fill out as much as possible by default, right? And the red dots is basically where you need to add, where you need to act, and potentially also on the blue ones. So in this case, I first want to create some contacts. We have 3 different types of contacts available with Marc, right? Glued contact, touching, which can separate again, and we can add friction, and a combination of glued and touching for parts that have some interfaces where they should be glued together, but also other parts that come into contact and separate again later. So in these situations that are very rare, we can use the glued plus touching. So in this case, I'll create a touching contact, and simply I could now maybe select everything and put friction coefficient to it, and that should be it, right? We will automatically define contact pairs for all the different parts. We can make it now here a bit more specific and also select contact pairs if you wish to do so. And we can then also, obviously define different friction values. Good. Then we have our contacts defined. Next is, for now, element technology allows you to switch between first and second order elements. We always start with first, which is almost all the time good enough here with Marc, because Marc has really advanced finite elements that can also support incompressible materials, bending cases, and so on with first order elements without severe locking and other negative effects. So now we add materials. We pick from the library, maybe simply use the PA material here for these parts, and we could use maybe aluminum for the plates. So this design is typically in you find it in automotive engineering, right, to connect plates together, or plastic parts to be fit. And on a boundary condition, we want to match these two parts together. For now, we could, for example, measure how far are they apart. If you don't know it, go to the measure tool and see the normal distance is now 6 millimeters. So we apply here with a formula a 6 millimeter movement in a negative Z direction, and apply this to the top face here of the pin. Right, and then we fix the side faces here of our plates, and we're basically done with our setup. We can maybe quickly talk about the material a bit more in detail here. I quickly brushed over it. So we start with linear elastic, but obviously we have additional material models available. For rubber and similar parts, we have hyper-elastic material behaviors, starting with Mooney and Ogden up to third order. And then you can also choose for metals then an elastoplastic material, which you can simply use with bilinear, perfectly plastic, strain hardening, or you can directly define the stress strain curve with a table with a CSV upload to define your actual material response in more detail. More is coming every week. We come to this at the end of the webinar to talk a bit about what's exactly available now and what we will come in this and the next quarter. So now, after we have done the main setup, there's a few settings we could play around with later when we have maybe more complex situations. And the numerics, the default setups are typically fine. Simulation control as well. We have an adaptive time stepping that we can tweak if we need it, typically not. What's important also to note, since we're a cloud-based tool, the simulations are carried out obviously on the cloud with our partner Amazon Web Services. And by default, SimScale selects the ideal instance type, right? If it's 2, 4, 8, 16 or more cores for the specific case. If you wish, you could override this and you can run up to 192 cores with Marc on SimScale, right? So use the parallelization when you have really massive cases, you can go up to 192 cores, but really typically the automatic choice is the best with the most efficient setup. Obviously, you can select the types of fields you want to see by default in the results. You could, for example, look at the contact normal forces, the contact friction forces, contact states, for example, and then print this out as a 3D field. In this case, we're interested maybe in understanding the force that it takes to push the pin fully inside. So we create a sum area calculation item for the reaction force on the face where we push it down, and that's it. And we could maybe double check from the other side where we have fixed it, right, if the reaction force from the bottom side is exactly the opposite. So we do that. Also see the maximum stresses maybe. So in this case, maybe you're looking at the principal stresses of the pin throughout the whole insertion process. Right. And that's it, right? We have here blue, the meshing. As you see, the mesh settings are blue. That means it's optional. By default, we have what we call physics-based meshing. So not only the CAD geometry is taken into account, but also your simulation setup to implicitly create local refinements. And typically what you play with is the global fineness level from 5 to 10 maximum. 5 is the default, so we can keep it at it. If you want to play around or maybe locally refine or ensure an optimal quality mesh, you have here different types of refinements. We have an extrusion refinement that we could maybe add here to add specific layered meshing on the plates, right? Maybe just with 2 elements with a quad dominant mesh. So we have here a better element quality, and maybe do that as well on the other side. So we put it as well on the other plate. Or we could add a local refinement maybe on the pin or on the interface between the different pins, right? This side and this to have a smooth sliding, and then have here maybe instead of the 5, a higher resolution. You can obviously also, instead of the automatic sizing, have a custom sizing where you can define the mesh refinement manually. And that's it, right? You could now generate the mesh first and iterate over the mesh, or quickly start the simulation and go. And with this, the simulation is off to the cloud provider, and a couple minutes later, you'll get an email stating your simulation is done. We'll jump these few minutes waiting and go to another project where we have completed the setup and run the simulation some time ago. Yeah, so it took 9 minutes to do this insertion phase here with some. You see here, I added here now 3 elements over the thickness, but this is more or less a very similar mesh setup as I did before. And then, you know, the insertion force, we see here, maximum about 16 Newton is needed to put it in. And then it drops a bit, and it's increasing only when actually the pin is touching the aluminum plates. We could now refine maybe a bit more to get a bit smoother curve here, or maybe use a second order element for this. Yeah, or for now, we can also check back on the results in the post processor. Right, we're looking here at the displacement in the different stages of the insertion process. We can obviously change the result fields to other fields that we have computed during the calculation, and that's about sums up the whole process of setting up a Marc simulation on SimScale from start to finish. And the great thing on SimScale is this is basically the exact same workflow for Marc, or for maybe setting up a heat transfer analysis with another solver we have available, or thermomechanical or harmonic or a frequency analysis, right? So the process of, you know, you get a template with default settings, add the red parts manually and then hit go, is very similar. We can also reuse the mesh, for example, that we previously generated for another simulation. And even the CFD analysis looks very, very similar to what we have here. Okay, with that, yeah, we could have a look at other cases as well. So this, what we're seeing here, this lattice book compression test, a bit more involving with contacts and self-contact, which is a very unique feature of Marc available on SimScale that we don't have with the other analysis types. So basically a part that touches itself during deformation. That's something that is only possible with Marc on SimScale. Okay, now we can answer more questions later, specifically on the simulation settings. But now let's go back quickly to the presentation. So yeah, we have seen maybe why this partnership is so important for SimScale. So obviously, the normal SimScale user experience is still the same with Marc. So the easy setup, ease of use is there. I mean, it's proven by our reviews that we get with, for example, G2 Crowd, where people are really happy about the usability of the software. More importantly, Marc is typically faster than the existing nonlinear solver on SimScale, and that is the difference is bigger the more complex the simulations are, right? So for simple linear static analysis, it's the same. And then if you add contact, if you add friction, nonlinear materials, the difference gets more evident. So this is a typical, I think a typical range that we've seen in all our tests is about 4 times as fast here in this case, with exactly the same mesh, exactly the same setup, material properties, and so on, with the current solver based on Codaster, or the past solver based on Codaster that is still with the other structural analysis types, and now here the nonlinear mechanical analysis type powered by Marc. Right, so 25 minutes instead of close to 2 hours. And obviously Marc is very stable. So really we can go and explore a lot more new studies that we would shy away in the past, that now our customers are also able to do. So here's a customer for Hexagon that deal with complex physics for seals in hydrogen applications, so large deformations, high pressures, rubber materials, and for this Marc is ideal, right? So this is the perfect solver for our CAE teams. Here the comment from Amit from Hexagon. Yeah, and that's what where we currently stand today with Marc on SimScale. So these applications of rubber-like materials, bushings, O-rings, sealing applications, snap fits with friction. This is exactly the current perfect use case for Marc on SimScale. Where we have these complex contact situations, there it shines. And we can now really do large studies with not only a single part, as shown here, like nonlinear buckling behavior, but also very large assemblies with a much simplified approach to contact definition. As we have seen, we have a body-to-body, a volume-based contact definition, so you don't need to select the actual contact faces anymore. And with this, we're almost at the end. I'd like to take the last few minutes before the Q&A to walk you through the current or the soon-to-come features on top of what we've seen just now in the live demo. Another great advantage of a cloud-native tool is we release frequently, right? We release multiple times a day across the broad applications on SimScale, right? It's not everything is only updating a new solver, a new boundary condition. It's a lot about meshing the viewer, the backend. So multiple updates on the platform per day. And weekly, we're adding features now for Marc on SimScale. So expected for Q3 are, for example, the elastoplastic material behavior that we actually have already shipped, and you've seen that today. The symmetry constraint is also done. This is in the final Q&A stages. It will come latest by next week. And then you have the Marc native symmetry condition, which acts a bit more like a contact condition against an infinite plane, which allows really the large deformations and contacts to intersect the symmetry condition in a robust way. And then we are working on multi-step analysis. So instead of having just a single load step, you can add multiple load steps, as many as you want, and you can deactivate and activate boundary conditions and contacts for each individual load step separately. And this gives you a lot of flexibility to first do the load step where you maybe do the assembly phase first, right, where you can fix a part, put them into place, activate the contact, and then in the second step or in the third step only apply the load. And this allows really for much more complex situations to be solved with SimScale and Marc. Automatic contact detection is also coming. It's also in the latest Q&A stages, so you don't have to actually define all the glued contacts by default. We generate them automatically, and you might only switch then from a glued to maybe a touching type for actually enabling friction and separation on certain parts. And yeah, last but not least, we add more boundary conditions. The RB2, RB3 connections are coming. So you can now, then also add rotations from a remote point, apply moments as well as forces onto the parts. And then, more materials and live results. So the live results really helps you see issues with your simulation run early, so you can cancel it, redo the settings and run it again, so you're faster again in iterating through your design process. Right, so if you take a step back, there are some larger features that will come then after Q3. This is the current state of the roadmap. As always on SimScale, we are very receptive to customer feedback. So, and that's now exactly the time where the roadmap is shaped a lot with customers testing and using Marc the first time, and where we get feedback, and we might reprioritize this list a bit towards the end of this quarter. But so far, you're pretty confident that we will add the thermal effects as well, right? So you can take into account the thermal expansion, dynamic effects as well. So you can do drop tests, right? And then really make more use of the self-contact features for large deformations. And it will go on with more material models, more boundary conditions, and structural elements. This is something that we recently revived again by adding more capacity to the structural development on SimScale. So we have a clear goal in mind about adding shells and other structural elements to SimScale as well. And with it comes obviously also the need for local coordinate systems. And that is about it. I want to leave 50 minutes, a bit time for questions. So as a summary, I hope I could convey that Marc is really a powerful tool, and it has a very good combination with SimScale, with the broad additional set of features, right, on top of the solver, with the user management, with the data management that we touched at the beginning when we looked at the dashboard, and of course the AI features that come basically for free with the cloud native platform. And Marc is available now, right? Try it out. If you have a community account, you can try it out in non-commercial projects within the limitations of the community plan. If you have a normal SimScale professional license, then reach out to us, and we can also enable a test for you. This is really, I'm really excited to see the feedback, to see the projects that you all will be working on. And thanks again, Joanna, for the great presentation. And now we'll take some time to hopefully answer all of your questions.
Great. Thank you very much, Richard. And thank you, Joanna. Great presentations. We have had lots of questions. I've only managed to answer 2 of them so far based on my limited knowledge. So I'm going to be, yeah, let's see what we can get through in the time we have available. So to start off, they have a couple of questions about material models, and I think this was covered at least to some extent in your slides. So one question is, does this support material non-linearity? And I think the answer to that is yes, but then exactly which models are available as of now versus which ones are on their way? Oh, we seem to have, oh, yeah.
So yeah, we have seen it a bit. So currently we have linear elastic, obviously hyper-elastic models of 2 type, right? Mono-rivalent type and octane material, hyper-elastic material. And we will add more. So in this quarter, we will add, we had it here, I think, on this slide on Q3, we'll add Marlow material. So that's very convenient to add hyper-elastic materials from a pure test data set. So you don't need to do data fitting onto material parameters. You just directly use the test data to define the material. So this will be available end of this quarter, and then we'll add more as we go. Most promising candidates are the Chabosh material model for thermomechanical fatigue cases as well. Johnson-Cook, so straight rate dependency will come, and then also once we have also local coordinate system, orthotropic materials will come, and damage models which can be combined with multiple material behaviors. And yeah, if you need a specific model that might or might not be available today, let us know, and we can see if we can maybe, prepone the development of that in case there's a high demand.
Sure. Okay, so the next one is, are there plans to use Marc with SimScale's electromagnetic package to analyze nonlinear magnetic permeability?
That would require a longer answer. So currently short term, no, but we are thinking about the best ways to combine many analysis types on SimScale, and the development and the foundation of it has started already years ago, and we're in the rather final stages to provide a flexible backend that can be used to combine multiple simulations, right? So for example, run CFD analysis and then use the result of that for an FEA in a chained way, and then as a next step also in a coupled way. But a short answer is this currently not planned, but we will add more and more physics as well within Marc, and we have the electromagnetic solver, so I don't see why it shouldn't be impossible. It is more a question of having enough demand for it to make it to the top of the list.
Sure. I mean, yeah, and you also answered another question at the same time there, as we had one about, can you export, or rather, can you use the temperature and pressure fields from SimScale and from another SimScale analysis and use those in Marc for fluid structure interactions? I guess that's also answered there. Okay, I'm just having a look through here. Okay, well, so we had a couple of questions about meshing. One was, is the mesher being used a SimScale mesher or a Marc mesher? And I guess a related question is which
the SimScale.
SimScale mesher.
Yeah, this is we use the same mesher, so we haven't included yet the mesher that you might have with specific pre and post processors of Marc, like Mentat, for example. So the mesher that we use currently with Marc on SimScale is the one that we use for all the structural and most of the CFD analysis types as well. So it's a proprietary mesher that is multi-purpose basically, it's fit for FEA and CFD, and so far we had very good experiences with it. Yeah, should there be a need to add something specific that you might not find yet, let us know. A specific type of refinement or grading of the elements or similar. But yeah, so far it's a very robust and yeah, overall very good measure.
Mm-hmm. And I had another kind of under the hood question is, which version of Marc are we seeing there?
I think it's the 25.1, and we will update to the 2025.2 as soon as it's available, with maybe 2 weeks delay compared to the availability, right, when you could download it from the download center to just go through the typical Q&A process and ensure that all the tests are green. And yeah, we really want to be as close as possible to the general release cycle of Marc.
Can a deformed structure be exported? And I'm also going to combine that with another question, which was, can you also access the Marc, I guess it's the Marc model file, the .mud file?
Mm-hmm. Okay, the first one, you cannot directly export a deformed shape. Yeah, just a couple days ago, we put it on the roadmap in a very high position. I think we might be added in Q4. What you can do is you can obviously download the results, right? So you can download all the results that you generate on SimScale anyways. So we also provide download options for Marc. And it will come in a neutral file format in VTK. So with any type of post processor, something like a ParaView, for example, should be able to open the file, apply the deformation, and then export as STL. Right? But so far today, we don't have the direct option to download the deformed shape, but there's a way how it can do it. And what was the other question related? Sorry.
That was about, can you export a deformed structure?
Mm-hmm. Yeah, so that was answered. Yeah, you cannot directly. And the MUD file, I think, was the other question.
Right. Yeah.
We don't provide that natively, right? So we provide the general file formats on SimScale, which for the post processing is VTK as download, and then you see some solver information, in the solver log in the UI, but not the native Marc input files.
All right. I see another one here about will Marc be helpful, or will Marc be able to analyze anisotropic materials?
Yes. So as I said, we don't yet have the option available, mainly because it makes most sense to have it once we have actually also local coordinate systems, right? Cartesian, cylindrical, and then you can easily add the anisotropic material behaviors on top. SimScale users will know that with other solvers we already have options to create orthotropic materials. But yeah, these are rather limited without local coordinate systems. So we put it, as we anyways now focusing on these after the release of the local coordinate systems to enable the full capacity. Right, and in the meantime, if you don't have like super complex cases, you might be able to use the existing nonlinear static solver to hopefully solve that case.
Okay, and maybe one final question. Is there a viscoelastic model in SimScale?
Not yet, but we will add viscoelastic material models in, I think, Q4.
Okay.
I would be interested also to see if there's a specific, or to hear if there's a specific requirement on a specific modeling for the viscous effects. Yeah, let us know, maybe in another question, which specific model you would be interested, and then maybe I can answer by email if that and when it would be available.
Okay. We also had a question about whether there's a free trial of SimScale, and I suppose it's always good to reiterate the fact that you can access Marc with a community license. So if you sign up for a free community account with SimScale, you can run, I think it's 10 simulations, and you can use those to try out Marc analyses if you would like to use it for non-commercial testing. All right, I think we are out of time. Any questions that we didn't get to today, we will follow up with you individually. And but yeah, all that remains to say is thank you very much, everybody, for joining us today. I hope you are excited as we are about launching Marc on SimScale. Thank you to Joanna from Hexagon for joining us as well. And yeah, we will see you next time.
Thank you. Thanks, everyone. Thank you, Alex. And also, again, thank you, Joanna, for your time and efforts. It was a great presentation. And thank you to all the attendees. If you have further questions, don't hesitate to reach out.